All right, so you're welcome back to my class again today. Now we are going to continue where we stopped in the last class, which is what? Still on Bitwise Operator. And this was where we stopped in the last class. Now in this class, I am going to explain, last class I showed you this not or. Because of the sign integer, why it is giving us minus 61. If it is unsigned, it will give us a different value, right? Because we are using this format specifier as D. If it is unsigned, I will change this format specifier to U. And the moment I do that, it will give me a completely different value from minus 61. So these binaries in the memory has no meaning unless interpreted through the lens of the data type. That is very important. You need to note that. So today we are going to continue with exclusive OR and then the left shift and also the right shift. Let's get right in. All right, so to explain this exclusive OR, the operation of this exclusive OR is such that if they are the same, it will return 0. But if the digit differs, then it will give you 1. That is the exclusive OR. So in that case, using exclusive OR for this and this will give you 1. This and this will give you 0. This and this will give you 0. This and this will give you 0. This will give you 1. This will give you 1. And then this will be 0, 0. This is exclusive OR, right? So if I'm to interpret this, what will it give me? So that would be this one would be 2, 0 times 2 plus 0 times 2 plus 1 times 2 plus 1 times 2 plus 0 times 2 plus 0 times 2 plus 1 times 2, right? Now, this will give me 1. This will give me 0, 2 raised power 0, 2 raised power 1, 2 raised power 2, 2 raised power 3, 2 raised power 4, 5, 6. One, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. No, it's not complete. That would be 0 times 2 plus 0 times 2 plus 1 times 2 plus 1 times 2 plus 0 times 2 plus 0 times 2 plus 0 times 2 plus 1 times 2. Now, this will be 0, this will be 1, this will be 2, 3, 4, 5, 6, and 7. So, in converting this to decimal, 2 raised power 7, that will give us 128, right? So, if this is 128, this will be plus 64. This will be plus 32. Then this one will be plus 16. And this will be plus 8. And this will be plus 1. So because this is 0, so this will be off. This is 0, this will be off. This is 1, this will remain. 1, this will remain. 0, this will be off. This will be off. This is 0, this will be off. So this one will remain. So 2 raised power 0 is 1 times 1, that is 1. So 32 plus this, that will give us 48 plus 1, that will give us 49, right? So exclusive OR will give us 49. This one will give us 49. I hope you are with me. If you don't understand what I'm doing here, please state it in the comment section. I will answer you. So this is how you convert binary to decimal. So that will give us 49. All right, so let's go to this left shift, and I will also introduce right shift. So we'll come here and then we'll clean this off. Let's clean this off. All right. So for the left shift, the left shift is A, left shift 2. So this is A. Now, if I'm going to do left shift, I'm going to shift the digit 2 times. So this one will go 1, 2. This one will go 1, 2. This one will go 1, 2. So this one will shift to this. That will be 1. This one will go 1, 2. That will be 1, 1. This one will go 1, 2. So that will be 1, 1, 1. So this one will go 1, 2. So it will come here. Then this one will go 1, 2, 0, 0. Right? So this is how it's going to be. Then I have 1, 1, 1, 1, 0, 0. 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. All right. So this is what I'm going to get for this. Now, interpreting this will give me 0, 1, 2, 3, 4, 5, 6, 7. What I'm simply doing is bringing in the binary conversion. So this will be 2 raised power 7. So this one will give me 2 raised power 7 plus 2 raised power 6 plus 2 raised power 5 plus 2 raised power 4. Every other thing here will be 0, right? So this will give me 128 plus 2 raised power 6, that will be 64, plus 2 raised power 5, that is 32, plus 2 raised power 4, that is 16. Half of this, half of this, half of this. That is mathematics for you. Then when I add all these together, that will give me 240. So the left shift will give me 240. Right? That is what that will give me. Now, should I still do the right shift? Right shift. Now, right shift to be A, right shift 2, like this. So that will be this one, shifting this way. So that will go 1, 2, 1, 2, 1, 2, like that. So this one will give me 1, 1, 1, 1, right? 4. So they will shift into 4 places, then 0, 0, 0, 0. So that is what this will give me. So if I'm to convert this, what will that be? So this one will give me 0, 1, 2, 3. So this will give you 2 raised power 3, which is 8, plus 2 raised power 2, which is 4, then 2 raised power 1, which is 2, and then 2 raised power 0, which is 1. So this plus this will give you 12 plus 4, that is 14, plus 1, that is 15. So right shift 2, which is this, will give us 15. Now let's go to code blocks and let me demonstrate this for you to see. If you have come with me this far, please don't forget to click on the subscribe button if you have not done so, and also give me a thumbs up. And if you are not following me on my Facebook page, you can also follow me. So let's go to code block. All right, so this is our code block. I've written the code already because I don't want the class to be too long as usual. So I'm just going to run through this, which is exactly what I've done on the board. I brought in the preprocessor, which is what included stdio.h. From there, I'm going to use my printf. Then I have the main, which is where I'm writing the code. Then you can see that I wrote everything inside here for you. the AND operator, the OR operator, the NOT operator, the exclusive OR, left shift, right shift. Then I return 0, which is what my main is returning to the operating system. I told you. So I'm going to execute this script for you to see what the output will be, just like what I explained on the screen. So I'm going to compile, build and run. So which is I'm going to compile it and then execute it. So I do that. So you see the output. The AND will give us 12, which is what I explained to you, and I've explained to you how we achieve that. The OR will give us 61. The NOT will give us minus 61 because it is a signed integer. Now, if I change it to unsigned integer and then I use the unsigned format specifier, this one will give us minus 4 something. It's just going to write gibberish. Let's try that and see. Let's say I just change this place to unsigned, meaning I'm saying interpret the binary from the unsigned realm of the integer. What will it give me? So let's execute that again. Now, can you see? So it's giving me 4294967235. I can equally explain how the system achieved this on the board. But this was just to show you the difference between signed and unsigned integer. So for the unsigned, there is no negative value. For the unsigned, there's no negative value. So it's showing you the positive side, right? That is what is given to you. All right, so that's what I want to show you in this class. Don't forget to give me a thumbs up. So to see in the next class, which will be the assignment operator. Till then, bye.